Hello and welcome back to this tutorial series on Unreal Engine Audio. As many of our upcoming tutorials are going to involve working with Blueprints, this tutorial is going to be going over the different audio tools available in Blueprints. This will be covering a lot of information, so there will be time codes included in the description and the timeline for each of these sections. For these examples, we will be using bookmark 9 in the engine in order to have plenty of space. As a reminder, to go to this location, just press the shortcut key 9 above your keyboard and you will be teleported there instantly. So, in order to actually create a blueprint, all that we need to do is right-click in the folder just like we did in previous tutorials. For this case, I'm going to be going to Audio, Blueprints, and creating it within here. So, first we are going to right-click, we're going to go up to here to create basic asset, or you could go down to Blueprints, and then you just click Create Blueprint Class. Now, we're going to be picking the most basic version of the actor, which is just an actor itself. So all we have to do is just click on actor here. It'll pop up in our folder, and then we can type in the name Blueprint Basics, press Enter, and our blueprint has now been created. Then all we need to do is double click on the blueprint to open it up. Now, sometimes when you click on things, it may pop up in this separate window. All you need to do is just grab the top tab here and drag it onto here to actually get it locked. Now also, when you sometimes create new blueprints, or if you're clicking on older blueprints, it might just show you this tab right here. All this does is show you the data only. So only the default values are shown as it says up here. And so if we wanted to open the blueprint editor like we saw before, you just have to click Open Full Blueprint Editor. And we are greeted with a blank blueprint. The only components that we actually have within the components view is the default scene root. So to make this a bit easier to visualize, what we're going to do is we're going to add a visual aspect to our blueprint. So in order to do this, what we need to get is a static mesh. Now, a static mesh is a non-moving skin for your blueprint and will allow it to be seen within the level. So let's click on our default scene root and click Add Component. All we're going to do is type in static mesh. We can just click that right here. Now I'm just going to title this rock because that's the static mesh I'm going to be choosing. We'll go in here, go to our static mesh, and just like before with choosing a sound, you can either click on it in the content browser and bring it in, or you can click here, and I'm going to look for stone. We're just going to choose this SM Stone Big Variation 2. You can choose any static mesh that you want. This is just the one that I chose to use here. Once I click that, as you can see, we now have a visual aspect to our blueprint. If we look at our event graph, we can see that there are a few nodes already present within the event graph. The reason that these nodes show up is because we chose the actor class. Due to this, the engine automatically provided us with the most common nodes used in actors. These will vary depending on what blueprint classes you create. To talk about events, I'm going to be showing you how these basic events work. So for this, I will be using the sound node Play Sound 2D. So in order to get that, you just right click and click Play Sound 2D. As you can see, we have the node right there, and if we click on it, we now have that node within the engine. Now what this does is play a sound in the speakers coming from no particular location. In other words, it doesn't have an attenuation and fills up the entire stereo field if you're using headphones. In order to connect these nodes together, you just have to drag from the output of one to the input of the other, just like sound cues. There you go. These are the outputs, and this is an input. As you can see with the events, they do not have an input. It means that it is the start of functionality within the blueprint. There's nothing that can be inserted into it. The first node is the event begin play. So to give you an example, for the Play Sound 2D, I first need to select a sound. Let's choose Village Wind. We compile and save that. What this means is that as soon as I start the level, this sound will start playing within the level. There you go. We can hear the sound playing, and it started as soon as the level began. The next node that we'll be talking about is the event tick. event tick is an event that is called every frame of the game. So for this game, I believe we are running 30 frames per second. So if I were to call play sound 2D, it would play 30 times a second. Now to disconnect any of these nodes, all you have to do is hold down Alt while clicking on it, and it will automatically get rid of that. So let's connect up event tick, compile and save, and if we play the level, as you can see, it was playing it 30 times every second. The final basic event is known as Event Actor Begin Overlap. This for me has been one of the most useful events to use when building ambient sounds. What this means is as soon as something overlaps with part of the blueprint that has collision functionality, it will trigger something to happen, such as a door opening or a sound playing. But one thing that must be present in the blueprint for this is something that is collision sensitive. Now in order to add this, we will be adding a sphere collision. There are other types of collisions, such as box collisions or capsule collisions, but for us, we'll be starting with the sphere collision. In order to do this, we can go back to the viewport, or we could have just added it to the components, but I'm going to click Add, type in sphere collision, click on that. The reason you can't see it right now is because this rock is actually taking up the space that the sphere collision is using. So let's make this a little bit bigger by using the scale objects. There we go. Alrighty. Another way to adjust this is to use the sphere radius right here. So if we use that, that actually adjusts what size radius the sphere is using. But for now, let's do it right about here. Compile and save. So if we go back to the event graph and we reconnect up this play sound 2D, what this means is as soon as we walk over that collision, it'll play this sound. So let's start the level. So when we first go in, there's no sound. But then as soon as we overlap, you can hear that the sound starts playing. This is great to use when triggering different sounds within the level. Say you want to walk by and you hear a creak or you hear a bird chirp or something like that. This is a great way to use those triggers within your ambient sound design. There are many more events available within Blueprints, as we can see if we type in events to the Actions tab. There are lots of different events that we could use, but some other common ones outside of the basic nodes are bind an event when a key is pressed under an input. Say you could type in J input. You can see these keyboard events that you can use. This would mean that when you press J, it triggers a sound or an event. There's an event when the actor is hit. There's an event when the actor gets destroyed, and much more. I would recommend exploring these in more detail to see how you can get things to be triggered within your level. However, you can also create your own custom events to be triggered at certain points in your blueprint. Say you want an event to be triggered after you overlap with the actor. One way to do this is to directly connect the two nodes, but another way that can help simplify your event graph is by using a custom event. If we right-click in the graph, we can type in custom event and click on that. Then we just title it the way that we want with rename. Let's title this overlap. Now that we have this created, if we drag off the actor begin overlap, we can type in overlap, and then we can see our custom function that has been created. So if we click on this, what this means is that as soon as this is triggered, it will trigger this custom event to start playing, and then in turn, play our sound 2D. This may seem like a little bit of a roundabout way to do this, but this can be quite helpful when you have very large and complex blueprints in order to trigger certain things at different parts of the blueprints without having to drag all the way across the event graph. So let's see this in action. Go into the level, overlap, and we can see the sound was triggered just like before. Another interesting use of custom events is that they can actually trigger events in other blueprints, but we will be talking about this at a later time. So far, we have been using Play Sound 2D in order to play our sounds in the level. However, there are several other ways to have sounds play using a blueprint. There are 5 basic audio nodes that can be used in blueprints. The one that we already have been using is Play Sound 2D. The next one we will talk about is Play Sound at Location. This is similar to Play Sound 2D in that it doesn't actually place an actor in the level, all that it does is play a sound. However, while Play Sound 2D plays a sound that fills up the entire sound field, Play Sound at Location places a sound at a specific location and gives it an attenuation. This allows for spatialization to occur. In order to specify the location of the sound, you can either type in the world coordinates, or you can use a node that gets the location of the actor that you want. In this case, I want the sound to play right where the actor is. So I'll be using the node getActorLocation to find the location of that actor and place it into the node. So if we type in here, getActorLocation, so you can see it pops up right there. Now currently the target of this getActorLocation is the self, which means it will target this blueprint, but you could attach this to other actors within your level if that's the location you wanted. We could take this return value and connect it up to the location node. Then, if we make this sound the village wind again, attach it to actor begin overlap, we can hear in the level that as soon as we walk through, the sound now plays, but as you can hear, it is now in a specific location. The difference between the play and spawn nodes is just that. The spawn nodes actually spawn an actor into the level. This means that the actor spawned will not go away after the sound is finished playing. It actually returns a reference to the game that can be manipulated at other points in the blueprint. This can be useful when you have sounds that you want to reference and use multiple times throughout your game. It is also the only way to manipulate the sound as it is playing in real time. While the inputs that you see are the most common one used with these types of nodes, each of these has hidden settings that we can access by clicking on this down arrow right here. So a few of these settings are shared by every node. We've got the sound, which allows you to pick the sound that you want to play. We've got the volume multiplier, pitch multiplier, as well as start time, which in this case determines where in the sound node you want to start, so how many seconds in. And they all have concurrency settings, which we will be covering in a different tutorial. However, there are different settings for each of them based on what you can do with the particular node. For Play Sound 2D, it doesn't need a location because it is played in the entire stereo field, and hence the only other settings are the owning actor and the is/UI sound. Owning actor is used for concurrency as well, which we'll be covering later. The UI sound means that it is UI related or user interface related. Otherwise, it would be false, which in this case we would want to turn that off since we are just playing it within the level. However, a lot of the times, Play Sound 2D is used for user interfaces such as menus, because that does take up more of the space and it's not necessarily occupying a specific location. Spawn Sound 2D is similar, but instead of owning actor and UI sound, it has settings for persist across level transition and auto destroy. Persist across level transition is used when switching between levels. An example of this would be if a portal sound was playing as someone teleported from one level to another. By default, this is turned off. The auto destroy feature is a feature that is included in all of the spawn sound nodes. Since it is actually spawning an actor in the level, you have the option to have it automatically be destroyed in order to save memory. The way that you would know when to destroy it is that as soon as the audio is finished, it will destroy that actor. If it's unchecked, that actor will continue to persist within the level until you specify for it to be destroyed. For sound at location, the spawn and play nodes are quite similar. The difference between the two are the owning actor for concurrency, as well as the initial parameters, which allow you to set the initial parameters of the sound, which these you have to create an asset for that in order for this to be used. Finally, the main difference with the spawn sound attached is that you can attach the sound to a moving object. This allows you to name the actual joint or component that you want to attach it to, which determines how the sound behaves when the thing it attached to is moved, and gives you the option to destroy the actor when the component that is attached to is also destroyed, which would make sense in most cases. This node is the node that you should always choose when you have an actor that is moving around the level, because you want the sound to be following it rather than consistently changing the location. One thing that you might have noticed as we've been going through this tutorial is that each of these node inputs have a particular color. The reason for this has to do with what type of variable they are compatible with. For instance, the volume, pitch multiplier, and start time all have this green node for inputs. If we hover over the node, we can see that this is a float input, which is a number that can have decimals. This is the opposite of an integer, which is only whole numbers. This means that the only type of values that can go into the volume are floats. If we tried to put the actor location in there, it wouldn't work because it is not compatible with that variable type. In order to set these values, it can be useful to type in the exact values that we want. However, if we want to have these values changing during gameplay or to make our lives easier, it is not the most efficient method. In order to make our lives easier, we'll use what are known as variables. Variables are items that can hold a certain value and can be changed or read within the blueprint. There are two ways to create variables within blueprints. The first way is to click the plus sign next to the variables icon and choose what kind you want. So if we just type in variable, we could go in here and choose that we want the value to be a float. Or we could choose any of these other variable types, which we'll be going over a little bit later. The second way is to drag off of an input and choose promote to variable. So say if we wanted to promote this one in particular, if we drag off that, we see this option at the top that says promote to variable. Then if we click on that, you can see that it automatically creates a labeled variable of the correct type. If we want to set the volume elsewhere in the blueprint and have it match what the volume of this is, we can now do that using this variable. So if we wanted to use it at other points in the blueprint, we can either use the get or set functions, which get means you can read the value, and set means that you can change the value within the blueprint. A quick shortcut to be able to do that, rather than just dragging off and choosing, is you can hold Control click and drag in order to get, or you can hold Alt click and drag in order to set. Once we have our variable selected, we can see the details panel. This has the name of the variable, variable type, optional description, and some more gameplay-oriented options. The one that we are going to be focusing on is the instance editable option. What this means is that when you drag a version of this blueprint into the level, you are creating what is known as an instance. This is a copy of the blueprint that contains all of the features of the original blueprint. You can do this either by checking the instance editable over here, or you can go over to the variables section and click on this eyeball in order to make it instance editable. Open means editable in instances. Closed means it's only editable within the blueprint. This variable can now be used at multiple locations throughout the blueprint, either connecting to multiple spawn sounds or play sounds, or you can have the value set by another part of the blueprint. Then, once we have set those, we can determine what the default value is for the variable. If we drag off of one of these nodes, the default value will be what value is listed within the node, in this case 1. Otherwise, we can just change what this value is to set what the default value will be within the level. We have now covered the basics of blueprints in the Unreal Engine. There are many more avenues and rabbit holes to go down, and some of these we will be covering in the next tutorial on more advanced tools and blueprints. I hope this helped you on your audio journey, and I will see you in the next tutorial.